cylinder, cone, and sphere. So we would be learning the formulas of all these shapes in it. All these are geometrical shapes. So first of all, let's take the cylinder. What is a cylinder? See, if you keep one bangle, you must have seen a bangle. You keep one bangle here and you keep another bangle over it, another bangle, you can see the shape it has become. So will it not give you hollow cylinder? Yes, it will give you hollow cylinder. So you can understand, imagine that hollow part. This is the surface part, right? Right, this particular surface which is curved in nature, so we call that as a curved surface area, right? Curved surface area. Then how to find the curved surface area, right? That could be one question in it. Then at the top you will see it's a complete circle. If it is full, consider it as a tin can. Remember, the Coke tin can is filled, its top here is a bottom and it has a curved part of it. Tin can is what is a cylindrical shape. So what about this? Is it not a complete circle? It is a circle. Fine. So it will have a certain area. This also will have a certain area. So the area of the curved part and the top and the bottom together will be called as total surface area. Fine. Now then it says, say the area of cross section. Area of cross section is the same thing, which is the area of the top or the bottom there, right? This is called cross section, or we can say simply area of circle, or top or bottom, same thing. So area of the top is, the formula for that everybody knows, is pi r square. Area of the bottom is also the same because it's cylinder here, that will also be pi r square. Curved surface area is basically the length of one circle into height. So what is the length of one circle? Length means perimeter. So perimeter of the one circle is 2 pi r, which is the circle here. Remember, we drew the base. The one perimeter is how much? Perimeter is 2 pi r. If you multiply that with height, it will give you the curved surface area, the entire curved part. So remember, perimeter of the cross section into height will give you the curved surface area, which is a circumference, or the perimeter is 2 pi r. So 2 pi r into height h. Total surface area will be the cross section area, this area cross section area plus the curved surface area. So curved surface area plus 2 times area of cross section, which is the area of base and area of top, we can say, right? So area, this is the curved surface area, this is 2 times pi r square. We can take 2 common and even pi common and even r common. What is left? H plus r. So this is the area of the total surface area of this particular cylinder here. So area of cross section. Okay, and now comes volume. Now to understand the volume of a cylinder, consider that there is a circular, something circular which you have taken here. Maybe cardboard, circular cardboard. You keep one other circular cardboard in it, another one, another one, another one, another one. It will form what? It will form circular cardboard until here, right? Fine. And will it be hollow? Will it be solid? It will be completely solid, right? So if it is a solid, then I mean you can't put your hand inside that. Simple, because it is solid. Then has it not given the entire content? Is the volume here? Fine. So the volume of this particular cylinder would be, okay, what has given the smaller one? Earlier it was simply a bangle. Now it is a complete cardboard. So it's cardboard has got area and this has got circumference. This has got circumference, right? And this has got area. So area of base into height will give you, area of base into height will give you what? The volume of this. Remember, the circumference of the circle or base into height will give you the curved surface area, and the area of base, right, which is circular base or cross section into height, will give you the volume of it. So this is the area of cross section into height, is give you volume, and volume is pi r square is area of the base and height is h. So volume is pi r square h. So remember, these are the formulas, you have to note it down. So we can use that. Now comes important part here, hollow cylinder. What is a hollow cylinder? Say, even this case was a hollow cylinder, right? We did not consider the thickness of the tin. which is it made up of. So now we'll think of, say there is some thicker kind of let's consider like say a wooden hollow cylinder. So how do you make a wooden cylinder? So you take what the entire thing, remember, you take a complete cylindrical solid wood. This is a solid wood, fine, and with a machine or something you make hole into it exactly like this, exactly. You make a hole of it and you make a hole exactly like this. Then what you're left with, you're left with this thickness, right, which is this one, you can see, right, and there's nothing inside it. So understand here, very simple. If you have to find the volume of this particular wood by which this is made up of, so what do, you first of all, you had taken a hollow cylinder, sorry, complete solid cylinder. You take the volume of a complete solid cylinder. So with that, okay, if the radius of this particular bigger, okay, outer one is how much, say capital R. So what is the volume of this one? The volume here will be pi capital R square, and if the height is h, it will be h, right? Now the one which you have made a hole, then how much you have made a hole? If you have made a hole using this particular what, radius, right? So you will find the volume of this particular smaller circle, a cylinder of the smaller circle which was made as a whole, right? So what is this radius here? Radius is r, small r, fine. So what is the volume of the smaller hole, which is V is equal to pi small r square h. Was it not removed? This part was removed. So this, from this part, this was removed. So remainder would be what? You will say volume of the remainder here. That will be, say, if this is volume of the capital R and this is small r. So it will be volume of small capital R minus volume of small r. So volume of the remainder would be, remaining wood would be how much? V, the volume of the bigger one, which is pi capital R square h, and minus pi small r square h. So what is the volume left over? You can take the pi common, h common, so r square minus r square. So this is what is given here. If you have to find the volume of the wood by which it is made up of, that volume will be, you take the volume of the using the outer radius capital R, and you take the volume using the inner radius small r, you subtract this volume from the bigger one, you will get the volume of the wood remaining. And even you understand, when you made a hole in it, what was left? There was nothing in it, air. So we can say this part is filled with air and this part is wood. If you take the bigger radius capital R, then you have found out the volume of air plus wood. And if you have taken the smaller radius, you have found the volume of air. You subtract the volume of air from the volume of wood plus air. So say wood plus air, and you subtract volume of air. So what do we get? This will get cancelled. Volume of wood is left. As simple as that. So this is the formula here. The volume of total volume here will be here pi capital R square, pi h common, and r square minus r square. Simple. External volume minus internal volume. Now come the surface area. Okay, let's seek in thickness first of all. Let's see thickness of the wall. So thickness is what? How thick is it? So thick is this much. If I mark it with a red color, you can understand. Say this is the thickness. And how do you get this thickness? This is the total capital R minus small r will give you this thickness. So capital R minus small r. Now comes area of cross section. So how do you find the area of this cross section? Which means area of this part. How will you find the area of this cross section? To find the area of cross section, you will take the area of the bigger circle, which is pi capital R square. area of the smaller circle, that is pi small r square, subtract it. So pi capital R square minus pi small r square, pi is taken common, so this is the area of cross section. So which we can say area of the wooden base is how much? This much, pi r square minus r square. If you multiply that cross section area with the height, you will get the volume. So this is the area of cross section, pi capital R square minus r square. This is the area of cross section, and multiply that with the height. This is the general formula for finding out any volume. If it is symmetrical, then it will be the volume, and that volume is into h, right? Now external curved surface area means if you have to find the external curved surface area, this surface area, then that will be using the external radius, which is 2 pi r h, right? If you have to find the inner surface area, this surface area, inside it, this surface area, you just look into it from inside, you will find this surface area. So that surface area can be found out by using the small r, so it will be 2 pi r h. Now total surface area is a big question, is a good one. You need to understand total surface area will be inner curved surface area plus outer curved surface area plus area of this base and area of the top. Area of inner curved surface area, external curved surface area, internal curved surface area, and area of two cross section, which is the wooden part, not the air in it, only the wooden part. So remember, inner curved surface area is 2 pi RH, outer is 2 pi capital RH, and the cross section area is pi r square minus r square, and for one and another one 2, so this is by 2 times here. So this is the formula for total surface area. You don't use a formula as such, but remember how it has to be found out, and if you keep on using the understanding part, you will never be having any problem in solving question. Otherwise, memorizing and applying the formula is some difficult task. Now come cone. What is a cone? Basically, it's a right circular cone, a cone which makes a 90 degree with the height here, we can say. With the radius will make 90 degree with the height from the vertex. So that is called right circular cone. Cone is if you have a cylinder, fine, if you have a cylinder and from this cylinder you curve out a cone on it. You curve out means this part is removed, this part is removed from it. So this will be cone, solid cone here in it. Then the volume of this cone is pi r, say small r in this case, square h, right? So the volume of this cone will be 1/3 of it, because this is 1/3, this is 1/3, and this is 1/3. So 2/3 has gone out, only 1/3 is left. So you can see the volume is 1/3 of a cone of a cylinder volume, right? Having the same area of base and same height. Clear? So remember this part. Now comes here, okay, it has got surface area. Now see what are the surface area it has. Surface area is, say, it has got two kinds of surface area. One is a curved part, you can see this is a curved part, fine, and another is a flat part in it below that. So curved part surface area can be found with a formula, and flat part is easily, that is pi r square. How to find the curved part? To find the curved part, we need to find this slant height. We call this is a height at 90 degree. This is the radius, and this is called as slant height. Slant height. How to find it out? Use the Pythagoras theorem. So L square is equal to R square plus H square. So L will be equal to under root of H square plus R square. As simple as that. And this, we got L. Now pi r L is the formula for the curved surface area. You can see this is pi r L, means pi into r into L is a slant height. L is a slant height. Multiply, you will get the curved surface area. What is the total surface area? Total surface area will be area of base. Area of base is always pi r square. So pi r square plus pi r L. You take the pi r common, what is left? L plus r, right? So this is the formula for total surface area. Volume, I already mentioned that here. Now comes another question here. If it is a a hollow curve, a cone here. You can see this is a hollow cone. If it is a hollow cone, then it will have, say, one of the radius is this one, another radius is this one. Say the bigger radius is capital R, smaller radius is small r. Fine. And this is the height in it. Height will be two of those. One height will be from here, okay, and that is from this point to this one. I'll just draw it here. You can see this is the height of the entire cone here. Now it will have another height in it, and that height is until here. You can see that. Fine. Now how to find it? If it is has been curved out, you can find the volume. So you can find the volume by what? The volume of the cone will be pi capital R square h. This is the volume of the bigger cone, complete cone. Say considering that this is the air part in it is not filled and this is the solid part in it. Right? This is the solid part considering. So what is that volume of the cone that we have found out is basically is air and solid. What is it? That is equal to volume of air plus solid. Got it? Now if I subtract from the volume of air and volume of solid, volume of air, will I not get the volume of solid in it? So how to find the volume of air in it? So if for that we need to calculate, this is solid here and air. Now volume of air, how do you find it out? Pi small r square, and this will have, okay, the total length was h, until here it was h. Make it capital H, so I'll make it capital H, okay. Fine. So this is small h. From here to here is small h. Fine. So that it will be pi r square, small square r, sorry, small r square h. Now volume of air. So if I subtract from this, what I'll get? Volume of the wood. So volume here of wood, right, or solid will be equal to volume of solid plus air minus volume of air, and that is equal to pi capital R square h minus pi R square h. What is common in it? Only pi is common. R square h minus R square h, and you will get the volume of solid in it. Fine. So this is, remember, you have to apply common sense only. May make notes of all of these, but understand that is more important. Now if you have to find the curved surface area, that will be a big problem. Say you will have the curved surface area of the bigger side by using the formula. If this is the slant, small capital slant height, right, and the small slant height is this one. So the total curved surface area, before we find total curved surface area, okay, we will find out the curved surface area of the inner part in it. So what is that? Inner part. So curved surface area of inner part is what? So we can say curved surface area inner is what? Pi r small l. Curved surface area of outer, pi capital R square, sorry, capital R capital L. Now then we have to find the area of this. You can see this part. What is that? Ring, we can call it as. So that is area of base, you can call, or area of ring. Fine. So we can say area of ring, we can call it as area of, and that is equal to pi capital R square minus pi small r square. Remember, bigger area minus smaller area, that will give you. So add all of these, that will be the total surface area. Total surface area will be all of these, pi rl plus pi rl, fine, and plus pi, I can take common in it, r square minus r square. Now pi is common in all of those, you can take common, so total surface area will be pi, and whatever is left here I can take RL plus RL and plus r square minus r square. Okay, so this is the total surface area. I have reduced it, all of these, and always reduce all those formulas before you substitute the value. It will say minimize your time of calculation on this. So remember, this is how we have to calculate, find out the total surface area. Total surface area means outer surface area, inner surface area, and area of this ring we can call, or base. Is it okay? Now comes sphere. Sphere is what you can, this is the sphere, right? If it is a sphere, it has got a particular radius. Let the radius be r. Then okay, you can find the volume by simply one formula, that is 4 upon 3 pi r cube, as simple as that. And if you have, it has only curved surface area, it doesn't have any flat surface area. So curved surface area has a formula, simply 4 pi r square, 4 times pi r square. Now this is spherical sphere, solid sphere, this is a solid sphere. Now when we have a spherical shell, means there is a hollow cylinder, a hollow sphere we can call it as. How to find the volume? Again, you find out the volume of the total sphere. Okay, basically you can take it as inner part is filled with air and outer part is, this is the same if it is made up of some solid, right? Now, so total volume will be volume of air plus volume of solid. From volume of solid and volume of air, we subtract the volume of air. Will I not get the volume of solid only? So what is the volume of air plus solid? Using the capital R. So 4 upon 3 pi capital R cube, right? This will be 4 upon 3 pi capital R cube is the volume of air plus solid. And what is the volume of the air only? 4 upon 3 pi small r cube, because if I use a smaller radius, I have found the volume of the inner part only. Subtract it from there, you will get the volume of the solid part. So volume of it will be 4 upon 3 pi is common, r cube minus r cube. That's the volume of the material by which the spherical shell is made up of, right? Now comes hemisphere. What is hemisphere? Is half of it. Take an apple, you cut it into 2 equal halves. One half of that will be called as hemisphere. So surface area, okay, remember the total surface area of a sphere is 4 pi r square. What is that? 4 pi r square, right? Then half curved surface area of this surface area will be 2 pi r square. But it has one more surface area now developed, that is called flat surface area, and that area is pi r square. So pi r square plus 2 pi r square, will it not become 3 pi r square? So you will see the total surface area is 3 pi r square. Volume here will be simply half of the volume of apple. So volume of apple was 4 upon 3 pi r cube. So here it will be divided by 2, so it will become, so 2 by 3 pi r cube. So 2 by 3 pi r cube is the volume. Simple, right? Now comes here combination of solids. So what are the combinations of solid here? Remember, in the question when you start solving, it will not be very simple that you have to calculate the volume of sphere or cylinder or like that. You will have a combination. You can see in this combination, what do we see? We see that it has got a hemisphere and on that there is a cone. So if they ask you to find the total surface area, so you can see what is visible to you. If it is a solid material, then only thing you can see is this outer curved surface area and outer curved surface area of this cone. You can't see the flat surface area at all. It is not visible. So you have to imagine in your mind what is being seen, right? What is that you are able to see in your imagination. That area has to be found out. So we have to find the curved surface area of hemisphere and curved surface area of cone. So what is the formula for curved surface area of sphere? That is, we can say curved surface area of sphere and plus curved surface area of cone. So what is that curved surface area of sphere? 2 pi r square. What is the curved surface area of cone? Pi r l. Radius is same for both of them. You can see this radius for the cone and this sphere is same. So this is why we have put the same r. What is common? Pi and r is common. So 2r plus l is the total. And once you have reduced it, right, into this common, taking common, you can't further reduce, then you substitute the value, you will get the answer in it. Now if you have to find the volume in it, so total volume here would be what? The total volume here would be the volume of the hemisphere plus volume of the cone. So volume here will be, say, volume of say sphere plus volume of cone. What is the volume of sphere? This formula is 2 by 3 pi r cube. Radius is same for both of them. So pi r cube. Cone, what is that? 1/3 of pi r square h. What is common in them? 1/3 pi and r square. What is left? 2 r plus h. So this is the volume of the total system in it, total part, combined part in it. So you have to first reduce the formula to this minimum, then you substitute the value. This is how you will be able to solve the question in minimum span of time. Otherwise it will take a lot of time. Next question is, here you can see there is a cone and on that there is a small cylinder, sphere, but it's not completely, right, covering the entire cone base in it. You can see that. So we have to understand this, how to find the surface area. The surface area will be imagined by you, should be like this. This is the curved surface area I can see. Then you can see, I can see the area of this ring in it, and then I can see the area of curved surface of this particular smaller sphere, hemisphere basically. So you have to find those separately. First of all, you need to know the radius of the smaller one. You need to know the radius of the bigger one. So the bigger one has a radius capital R, smaller one has a radius smaller r. So you can find that. So if it is a curved surface area, the curved surface area of this sphere will be 2 pi r square, right? Fine. This is the curved surface area of sphere. Curved surface area of sphere, hemisphere, right? Hemisphere. Fine. And then curved surface area of which one? Cone. Plus this is the area of ring. Fine. Area of ring. Getting my point? Okay. Fine. So what is the curved surface area hemisphere? 2 pi r square. Curved surface area of cone. Remember, this is bigger capital R here in it. So this will be pi r l. Okay. Now, then area of ring. Area of ring will be pi capital R square minus small r square. You can take common in it. What is common? Only pi is common. Whatever is left over is your 2r square plus rl plus r square minus r square. And this is the reduced form. You can further reduce it if you can and substitute the value, you will get the answer. Is that clear? This is for the surface area. What about the volume? Simple. For volume, this will be volume of hemisphere plus volume of cone. Simple. What is the volume of hemisphere? That is 2 by 3 pi small r cube. And volume of cone 1/3 pi capital R square h. So add the two, you will get the volume of the entire thing in it. Is it okay? So, and see, it's not that yet done. You have to reduce it. You have to take common in it. I think I can take 1/3 and pi common. Whatever is left over, then you substitute the value. Is that okay? So this is how we have to solve it. Otherwise, it will take a lot of time to calculate for you. Now here you can see it has got a cylinder in which there has been hole made, and that is in conical shape. So if you have to find the volume of it, or volume of, say for example, it is made up of wood, and then there was a hole made by this conical, a hole was made in it, in the wooden part. Cylindrical wood was originally it was. Then how do you find it out? So what you do in this case is you have to find the volume of the cylinder, volume of cylinder, right, and subtract there from volume of cone in it. So volume of cylinder is what? Pi r square h, pi capital R square h, because this is a bigger radius, understood? R, capital R, fine, minus, and this has got smaller radius, it will be 1 upon 3 pi small square, and if it is capital H, remember this is capital H, height, and the smaller one has smaller h, so this will be smaller h. Take the common in it, pi, and then the remaining will be there inside it, and solve it. You can put the value. If you have to find the surface area would be visible. What is visible to you? I can see the base is visible to you from the other side. Curved surface area is visible, and this area of cross section, we can say area of ring, is visible to you. So you have to find that, and then inner surface area must be visible from the top here in it. If you look it from the top, so you have to find those areas separately. It will be curved surface area of cylinder plus area of cross section base, you can say area of base, plus area of cross section top, right? Area of ring we can call it as, fine, area of ring. And then one more thing that we have to find, that is area of what? Curved surface area of a cone in it, right? Curved surface area of cone. So what is the curved surface area of cylinder? Pi capital R square capital H. Area of base, this is base, this is pi R square, fine. Area of ring, this will be pi capital R square minus small r square. Area of cone, that is pi small r L. This is a slanted L. Okay, take the common, whatever is common you take it, reduce it, and whatever comes then substitute the value, will get the answer in. Is that okay? So remember, this is how we have to solve. This is how we have got the total surface area which is visible for us, right? Don't write the formula and put it, you will get wrong. This is what you have to imagine into it. Next comes here this figure. If you imagine what kind of figure it is, you see this is a cuboid. This is a cuboid, and on that cuboid what is kept? See, it's basically, if you have a cylinder, and you cut it half, you cut half of it, and that half part has been put into it. Is it clear? So basically, if you have to find the curved surface area, then you have to find this curved surface, the surface area of this side, even the back side, this side here, and this side, area of base here, this one, and the half the curved surface area of cylinder. Got the point? Half the curved surface area of cylinder. What is that? Half pi r square h plus all the 5 surfaces, which is length into breadth, plus, if this is the length, this is the breadth, with length into height 2 times this side and the back side, then breadth into height 2 times, breadth into height this side and the big side, and add them up, it will yield the total surface area. If you have to find the volume, in that case you have to find the volume of this box. So that is, what is the formula? That is LBH, volume of the box, plus half the volume of the cylinder, right? And what is that? Half. Okay, I think I made a mistake here. This was 2 pi RH, half of 2 pi RH. This is the volume I wrote here. Half of 2 pi RH. 2 pi RH. 2 pi RH is the surface area, right? Volume is half of volume. Volume is pi r square h. Got it? What is it? Pi r square h is the volume of this entire cylinder. Half volume will be half times. And LBH is the volume of box, this cuboidal box. Add them up, this will give you the total volume. They may ask you a question, what is the amount of air in it? So find the volume of this one, find the volume of half the cylinder. If you have to find here, this is a curved surface area. So you have to find the curved surface area of this part, which is going to be pi r L. Say if this is L. Then curved surface area of this one. This part is not visible to you. Remember, this part is visible to you. Fine. If it is in your hand, you can feel that. If it is kept as a somewhere fixed, you can't see that. You have to see in the question what exactly they're saying you. So this part is not visible at all. No way. So pi RL, then curved surface area of cylinder, that is pi 2 pi RH, area of base or cross section pi r square, and area of this part, which is capital surface, capital R and small r. So that will be plus pi capital R square minus small r square. Is it clear? This is area of ring, you can call it as. So with that, you can take the pi common and find the total surface area. Same way the volume would be 1 upon 3 pi capital R. Okay, this was capital R here, right? Because the bigger radius here, fine. Smaller radius is smaller, right? Capital R pi R capital R square H is the volume of this cone, and plus pi small r square H is the volume of this particular one. They have different height here in it. Is it clear? This has got different height. This is H. Got it? So using these, you have to take common and then substitute the value. So you have to understand how it has to be solved. Now another question is this one. Say if you just explaining what happens in it, you have certain amount of water, okay, in it. The level of the water is this much. And finally, when you put into it an iron ball, the level of the water will go up. So what does it mean? This has been the rise in the volume, right? And that amount of volume of water, so volume of water from here to here is what? Is because of this volume. So volume of, okay, this cylinder is what? Radius is same as this one. So it'll be, if they take radius is small r here, so volume of this cylinder will be what? Pi r square, and if this is the height h, and that is equal to the volume of this sphere. And what is that? 4 upon 3 pi r cube. You do not know the radius, let the radius be capital R, and this radius is r in it. Is it clear? So you can understand this question. Now comes here, this is an ice cream here. So in a softy ice cream, they give you what? They're asking how much is the softy part in it, that ice cream part in it, and this is what? So you find the volume of this entire bigger cone, right, from here to here, and from there you subtract the volume of the inner part in it, right? You will get the volume of the biscuit, that softy solid part which is made up of, right? And then you find the volume of this entire sphere, hemisphere, add it to the bigger volume here, and from there you subtract the volume of this part in it, you will get the total solid amount. Once again, see, if I make it like this, say this has got a radius small r, and this has got a radius here bigger r. From this you can be able to find out, if you find this radius smaller r, using this you find the volume pi r square h, this is the height. Then you will find the volume of, until here only is h, until there is h, capital H. You will find the volume of ice cream in this particular cylinder. Then you take the capital R and find the volume of hemisphere. So that will be, this is cone and this is volume of sphere. That will be 4 upon 3 pi capital R cube. You will find the volume of this bigger one. So this is the ice cream inside this softie, and this is this over one, like a cap on it. Okay, add them up, they will give you the volume of the entire ice cream. Is that okay? There's no need to get this. Now in case if you have to find the volume of solid part, then yes, for that you have to find the volume of this bigger cone. From there you subtract the volume of smaller cone, but you have to consider the two radii, two heights. One smaller height cone will have height until here, bigger cone will have a height until here, right? I had mentioned that in one of the previous example there. So fine, this is how you have a lot of combinations of figures which you have to solve. But remember, in each question you have to reduce the formula after taking common, then substitute the value, else it will take a lot of time to solve it and you may commit mistakes in it. Okay.